peeps, welcome back to some notes. This is on Unit 2's section on states of consciousness. So this unit, or this set of notes, is going to cover Module 22. So we're going to talk briefly about what consciousness is. We will touch on hypnosis, although that is not on the AP test anymore, but I like to touch on it because it is in your textbook. So first, let's talk about consciousness. When we talk about what consciousness is, we are referring to our awareness of ourselves and the environment around us. So there are different, what we call states of consciousness, different levels, so to speak, of consciousness. So for example, there's waking awareness when we're wide awake, there's daydreaming, there's meditation, etc. So there are different levels of consciousness that we experience based on different things. So consciousness is something that is linked mostly to the branch of psychology that is known as cognitive neuroscience. So cognitive neuroscience focuses on brain activity that is linked with cognition, or the way that we think. When we talk about consciousness, I want to make sure that we can differentiate between what consciousness is and is not. So in this section, when we talk about consciousness as our awareness, our waking awareness, we're not talking about consciousness as Freud spoke about it. So Freud talked about the conscious versus the unconscious, and he would define the unconscious as this, repository of our childhood experiences, and it changes our behavior without our noticing. So it's what's going on like this iceberg below the surface. That's Freud's view of the unconscious. Whereas right now, when we're talking about, if we say unconscious in this unit, we're talking about literally things that are going on that help us to be more cognitively efficient. So things that happen without our conscious effort, so to speak. So we don't have to think about things like breathing or walking all the time. It's things that happen more automatically, or things that are going on outside of conscious thought. So one aspect of looking at consciousness, some people look at it as dual processing. And if you're a computer guy or girl, then you might know a little bit about processing and dual processors. So this just means that it's this idea that we have sort of two minds working at the same time. So we have our conscious mind, we have our subconscious, or the things that are going on below the surface. So we have the things that we think about and put into cognitive, thought. We put it into words in our mind, so to speak. And then there are the things that happen without us really consciously thinking about it. So this is not to say that we have two minds, left brain, right? So we've already talked a little bit about split brain research and how a lot of myths about neuropsychology center around that research, and people ran with the idea of being left-brained or right-brained. So this is not what we're talking about here. We're talking more about this picture that you see on the right, with a conscious, the things that we're thinking explicitly, and then the things that happen without us necessarily realizing it. So I want you to think about these terms, and I want you to think about some of the things that you might do without thinking about it. So I like to think of it this way. What are some things that you do on autopilot? And then on the reverse side of that, what are some behaviors that require conscious attention for you? So when I think of these questions, I think, autopilot, man, I can't tell you how many times I have left work to drive home and I don't think about it. I just do it because I've done it so many times that now it just kind of happens without me having to think about it. And sometimes I'll be close to getting home and I'll go, oh, I don't remember making this turn or that turn because I was just, listening to music or zoning out, but my mind was automatically driving me home and making it so that I could get home safely. When it comes to behaviors that require conscious attention, that might be something like me saying thank you when someone gives me something, or me explaining how I'm feeling and putting that into words when I'm trying to, interact with another friend or close relative. So when we talk about dual processing, we break the mind into two parts. We talk about the unconscious mind, which is what is mainly going to help us deal with new challenges, things that we haven't experienced before, and then the conscious mind, which takes care of the routine, the things that we have to do every day or every so often, so much so that they become sort of automatic for us. Okay, now we're going to move on to Module 23, and we're going to focus on sleep, which is one major state of consciousness. So first, let's talk about a common term that you will hear a lot in this class and in a lot of science classes, which is the circadian rhythm. Your circadian rhythm is this rhythm that is just innate in your body. It's like a 24-hour biological clock. What does that mean? It means that there are certain things that your body does every 24 hours naturally. So some of those things include our levels of arousal throughout the day. So we all know that most of us, when we're first waking up, we're pretty sleepy. Then middle of the day or mid-morning, we start to wake up. Then we maybe dip again after lunch, and then we start to get more energy towards the end of the school day, and then we dip again and we fall asleep later in the day. So it's a little bit of a pattern throughout the day that's pretty consistent for most people. Now, we know that certain things can throw that off, right? We know that if you pull an all-nighter, or if you drink a bunch of Red Bull, or, if you do something out of the ordinary, then that can change. But most of us have a pretty consistent biological clock, and there are different levels of energy that we have. We get hungry at certain times, all within this 24-hour period. And this can change as we get older, or as we experience certain things. It can change based on the things going on around us. So sometimes, if you ever become a parent, you'll learn that a baby has a very different biological clock than an adult human. So those are things that we can sometimes see shifts as we get older. Now, I want to make sure, there's one thing that I notice that my students every year seem to only associate circadian rhythm with sleep. So be careful not to do that. It is not just sleep related. As you heard me mention, it does have to do with our energy levels throughout the day, but it also has to do with things like our hunger and other things. So it's not just a sleep thing. So be careful and don't say it's your 24-hour sleep clock or your, sleep. It's the rhythm of your sleep cycle. It is just a 24-hour biological clock. So it is just all the things that our body naturally ebbs and flows and does throughout a normal day. Now, there are other types of rhythms that are a little bit longer or shorter than 24 hours. So an ultradian rhythm is a biological rhythm that occurs more than once a day. So it might be something like getting hungry, right? So that would be more of an ultradian rhythm in the sense that you get hungry maybe around breakfast, lunch, and dinner time. So that gets sometimes programmed in us, but a lot of that is innate as well. Infraredian rhythms are a little bit longer, so those might occur once a month or even once a season. So an example of an infraredian rhythm would be like a girl's menstrual cycle, which happens once a month. Now we're going to talk about the sleep cycle. So the sleep cycle is a 90-minute cycle that our body goes through, and it has been measured by scientists, and scientists have determined that there are about 4 distinct stages of sleep that humans go through. So these are the stages you see here on the right. We're going to go through them in order. So they're REM, Non-Rem 1, Non-Rem 2, and Non-Rem 3. And we'll talk about what all that stands for and what it means as we go through this. So REM, R-E-M, stands for rapid eye movement. And that is what happens when you are dreaming. You'll see someone's eyes are shifting behind their eyelids. That's what we're talking about there. And then the other 3 stages are characterized as being non-REM, so there's no rapid eye movement during the other stages. Okay, so how do we know about these stages? Well, you've learned a little bit about brain imaging, and you've learned about EEGs and how we can measure brain waves by putting electrodes on the head, and it connects, and when the brain is more active, you see bigger waves, and then when it's less active, you see a little bit of a straight line. So this is how scientists have discovered sleep stages, and each stage is characterized by having different types of waves. So we'll start with beta waves. Okay, so when you're awake, your brain waves look mostly like this. So they're pretty active. There's a lot of up and down. So these are what we will call beta waves. And then when you become drowsy or really relaxed and you're getting close to falling asleep, you'll see that they get a little closer together and it's a little bit more solid. So that's going to be your alpha waves. And then we get into the sleep cycles. So alpha waves are pretty slow, relatively slow brain waves. So now let's talk about when you fall asleep. So this is what I was referencing just now with the EEG. So remember, we talked about EEGs measuring your brain waves, and this is common. This is what you see for sleep studies. If someone's being diagnosed for narcolepsy or other sleep disorders, then they might do a sleep test like this where they measure their brain waves to see if there's anything unusual going on. So you can see here, you can notice the moment that this girl fell asleep, right? You see a drastic change in her brain waves right about here. So that is the moment that she fell asleep. All right, so now let's talk about the stages of sleep. So first of all, we have non-REM 1 or stage N1 sleep. This is characterized by theta waves. So during this stage, this is when we experience something called hypnagogic sensations. Hypnagogic sensations are basically like when you're first falling asleep, it's almost like you're having a dream, but you're still kind of awake, and so it's more of a hallucination. And so a common one is when you start to feel like you're actually falling and you kind of jerk awake, right? So this is characterized by people kind of, if you've ever been next to someone who's falling asleep and they twitch a little bit when they're falling asleep, that's why they're twitching, they're having those hypnagogic sensations. So this is a sign that you're in the early stages of sleep. Okay, next we have non-REM 2 or stage N2 sleep, and this is characterized by brainwaves that look a lot more all over the place than the other stages, and particularly there's something in this stage called sleep spindles. A sleep spindle is when you get a sudden burst of sleep, of high activity in the brain. And there's also another type called K complexes. K complexes are not a bunch of brainwaves right next to each other, but it's one big jump in the brainwaves. So it goes really high and really low, and then it levels out. So these are both things that occur in later stages of sleep. So the K complex is a large wave that stands out, as you can see here. Both of these characterize stage 2 or non-REM 2. Next, we have stage 3 sleep, non-REM 3 or stage N3. Basically, stage 3 is deep sleep. So this is characterized by delta waves, and you can see they're nice, big waves in the brain. They're very slow as well. So this is when we have gotten to our deepest level of sleep. So I like to remember deep sleep, and I spell it D33P. SL33P, deep sleep. Stage 3 is deep sleep. All right, so that's how I remember that one. That's my mnemonic for this stage. And then lastly, we have REM. So REM is our rapid eye movement. It is when we have fast, random brain waves, and this is when you dream. Scene change. Hello and welcome back. Okay, so we were talking about the REM cycle of sleep. And so REM sleep is your rapid eye movement sleep. It's when you dream. And so this is how I like to remember, because in the word dream, REM comes in that order. So REM sleep is also called paradoxical sleep. And this is because while your body is resting and is inactive, your mind is very active. Your brain is very active because you're dreaming. And so this is why in some people, sometimes they experience something called sleep paralysis, because the brain is being active, but the body knows that you're asleep and doesn't want you to act out your dream. So it will it will sort of cut off the connection to your motor movement while you're in REM so that you don't act out your dream and sleepwalk and do all those kinds of things every night. And so what happens is that with sleep paralysis, this is a disruption or an irregularity with REM sleep. This is when someone is dreaming and they're in REM and they wake up and they're still dreaming, but they feel like they're awake, but they can't move their body. And it can be quite scary. A lot of people that have sleep paralysis or have experienced sleep paralysis say that they have a very similar dream, or they see the same kind of thing, and it's usually something that's a bit scary, like a shadowy figure, and then they can't move even though they're afraid and would want to run away or move in some way. They feel trapped, they feel paralyzed, and that's because they're dreaming, but their body is not acting the dream out and will not move, and they feel like they're awake. So it's like a waking dream, but it's sometimes very distressing. But sleep paralysis is actually fairly common. It happens to a lot of people, and it's just something that has to do with your REM sleep getting interrupted and kind of disrupted in a weird way to where you are not supposed to be conscious during that time, and so it causes this a little bit of discomfort, but there's nothing wrong with you. It's something that happens to a lot of people. Okay, so now I want you to quiz yourself on the stages of sleep that you just learned. So I'm going to give you some clues and I want you to try to guess which stage of sleep it is. So first, we have this type of waves, brain waves. These are delta waves. This would be stage N3 sleep, stage 3 sleep, or deep sleep, or also called non-REM 3. All right, what about theta waves that look like this? You might experience hypnagogic sensations during this stage. During this stage, you have slowed breathing and your brainwaves are very irregular. All right, so this would be non-REM 1 or stage N1 sleep. All right, next. This stage of sleep shows up on an EEG like this, with fast random waves. This is the stage of sleep when you dream. It's also called paradoxical sleep. That's right, it's REM. Next. Well, I gave it away. Next is non-REM 2. That's all that's left, right? So non-REM 2, your EEG looks like this. It's characterized by these types of brainwaves. This is where we spend most of our sleep cycle, most of our time in sleep. Characterized by two unique types of brainwaves. One is the K-complex brainwaves, so the really large brainwave, and then sleep spindles, which is a fast burst of brainwaves. All right, this stage gets shorter as the night goes on. This is when some kids will wet the bed. It is the stage that is most difficult to be awakened from. Hint, hint. It's also called deep sleep, which means it's non-REM 3. All right, let's do another one. Okay, during this stage, your heart rate rises. Your breathing becomes more rapid and irregular. This is when your motor cortex remains active while the brainstem blocks its messages. This stage gets longer as the night goes on, and it is REM again. Now I want to ask you a question. You've probably heard people talk about this before, so I wonder if you know an answer to this. What is the recommended amount of sleep per night? Did you know that most people would say 8 hours, and some people actually get a little bit less or a little bit more and feel fine? So there isn't a one size fits all. 8 hours is a good thing to aim for, but some people do just as well on 6, and some people need up to 10. So it's a little bit flexible. So let's talk a little bit about sleep patterns. First of all, we're going to talk about what affects our sleep patterns and then what happens when we have problems with sleep. So first of all, some things that can affect your sleep patterns. Number one is your genetics. So it may run in your family that you sleep better or worse, or you fall asleep quickly, or you sleep very deeply. There are some things that are just genetic. Other things outside of our genetics that can affect our sleep patterns include our culture. Think about the culture that we live in today. We live in a culture that sadly doesn't value sleep very much. I feel like we are encouraged to work all the time and be busy all the time and be active and stay up late and get up early. And so sleep is not a priority, I feel like, in a lot of cultures today, which is a little concerning to a lot of scientists because it is necessary and it is important for our health. But culture has become so focused on, filling all these hours in a day and trying to sleep less and trying to find ways to cheat our sleep. So that can be an element as well, the kind of culture that you grow up in. And also your environment. So for example, sunlight we know can affect our sleep patterns. When the sun comes up, it sometimes wakes us up, and when it's going down, we start to feel tired. That's because it triggers something in our brains that tells us that it's either time to wake up or time to go to sleep. And what this is a part of the brain called the suprachiasmatic nucleus. You can see it right here, and you'll notice that it connects to the optic nerve, which we'll learn about more later, which is connected to the eye. And then it works in chorus or in tandem with the pineal gland. So here's how this works. When the sun is up, when sunlight reaches your eye and it comes into contact with the optic nerve, that sends a signal to the suprachiasmatic nucleus that the sun is up, it's time to be awake, or the sun is going down, it's time to get ready for sleep. So let's say the sun is going down, and so the suprachiasmatic nucleus is going to send a signal to your pineal gland, which hopefully you remember releases melatonin. And melatonin is the sleep hormone. So when the sun starts going down and the suprachiasmatic nucleus sends that message to the pineal gland will start producing more melatonin to signal to your body that it's time to go to sleep. And the reverse also happens. So when the sun comes up and it's broad daylight, then that sends a signal to the suprachiasmatic nucleus, or SCN, which then signals to your pineal gland that it's time to wake up. And so the pineal gland will slow down its production of melatonin. Now, what happens then when you're on your cell phone late at night on TikTok, right? At 2 in the morning, suddenly that light is tricking your brain into thinking that the sun is up. And this is why a lot of people struggle to sleep these days, because so many of us spend time in front of screens really late into the night. We play video games, we're on YouTube, we're on our phones, we're working on our computers. So it's very difficult to fall asleep after that. And it's because your suprachiasmatic nucleus is telling the pineal gland to keep you awake. And so the pineal gland isn't producing that melatonin that you need to fall asleep. And this is why a lot of people will take melatonin supplements to help them sleep better.